Okay, I'm in the process of making a few video segments which are some subtle issues in using Catia for finite element analysis. Let me let me tell you what the plan is first, and then in a follow-up video segment, I'll actually make the parts and proceed with the analysis. All right, suppose you have an object like that. Okay, so actually I have made it here, and it is it you can think about this thing as a box which is winding, okay, and the cross section is a square, 40 millimeter by 40 millimeter, and the spine of this is being ribbed. The spine of this is a spline here, or center of curve is a spline, and this square is being extruded or ribbed along that spine. Okay, now if this end, the end here is clamped, and you apply, for example, a pressure on the side face, well, there's no problem. We can do that with CATIA, okay? But the issue that I want to raise is what if the pressure or the load or any other restraint is not on the entire face? For example, here's a situation. So we have a circular patch here, which happens to be also clamped in addition to the square on the cross section, which is clamped. And then we have a little rectangular patch here. Of course, this is not quite rectangle because it's on a winding surface. It's actually surface where a force is applied, 500 Newton. Let's assume that this is made up out of aluminum, for example. And then there is a little patch here where pressure is applied. So the question is, how do I get to uh, arrange things so that I don't have to apply it, I should not apply it on the entire face, but on little patches. Okay. Now, there was a video segment that I made about maybe a year, 2 years ago, where I briefly outlined a simple problem, but this is a little bit more involved. Now, and I'm going to do that for you. There's no problem. But there's a second part to this problem is that what if we are trying to do a let's think about it as extruded mesh, so that the mesh is made not of regular four-noded tetrahedral elements, uh, but of these Breck elements, eight-noded Breck elements. This is going to be more involved, and the strategies to solve a problem like this down below using the default elements in CATIA and the strategy for doing the one above are different as far as some subtle issues that we're going to consider. Okay, so I will do first the bottom one, which is well, first making the part and creating those features on it. Then I'm going to create a finite element model of four-noded Breck elements, four-noded not Breck, tetrahedral elements, and we come back and do the one above it, which is Breck element, in a later video segment. Now, these are some views, the coordinates of the center curve as a spline is given here. For example, center curve is made of 1, 2, 3, 4 control points, and the coordinates in millimeters are given here. And then once I do that, then I'm going to create these features on the side face. Now, I also want to tell you that we're not really interested in exact dimensions of these features and how they're created, but patches like that is what's more of interest to me. Now, there are different ways of doing it. For example, you can actually create a plane here. You can create a plane here, and on it, you create these sketches: a circle, a rectangle, and a square on that plane, and then use projection, projected normal to that side face. Okay. Of course, first step is to extract the side face so that we can do a projection into a surface. Okay. The other option is, for example, once you create those three sketches in the plane that I just described, then you can extrude it. See that? You can extrude it, you can extrude that sketch, and then you can cut the face that was extracted with this extrusion, or split it. Let's think about it like that. Then you're gonna get three things on the face that you're gonna fill, and then eventually you have to sew. Originally, I was going to do it like that, but I changed my mind because really that masks the purpose of this tutorial. So I'm going to create a sketch and then project it. Now these are topologically, they look the same, but obviously they're different. Okay, now if you go to the next slide here, notice that on the side face, when I do this thing as a free mesh in Catia, because I created those features, if I there's a circle, but if I move the circle, notice that you can see that the mesh, see that the mesh is respecting that feature. In other words, when it meshes it, it makes sure that the seam, there's a seam here, which is a mesh property, and this is why actually we can later on we can what do you call it? We can put a pressure on it, because or clamp it, put a pressure on this one. If you go here, the middle one, which is going to be force applied on it, if I move this, you see that there's a little square here, which is because of the feature that was created. So I put that thing so that you can see it. And same thing with the pressure here. If I move this thing, you can see there is a square there in the background where the mesh is respecting that feature. Okay, so let's go ahead and I'm going to stop this thing, and we we do the other video segment, which actually creating the part and doing a free meshing on it. Okay.